It's the spirit of Amazon, which is always, it's day one at Amazon. Day one is a state of mind.
Amazon starts from the customer. So whatever we're building, we are building something to solve a hard customer problem or delightful feature for the customer. So you should think about that, okay, you're not going to be building something which is nobody's going to use. So there's fashion domain, there are home security, and there are other domains we're working on. So you will get an opportunity to work on a whole suite of different domains and areas. And that basically becomes a highly exciting opportunity.
Things we ship is pretty much kind of tip of the iceberg. There have been a lot of technology development, science development, and some projects have failed, but what they've enabled us to do is to actually become stronger, understand our failures faster. So this whole concept of fail fast in Amazon is just amazing.
There is no limits to who you can reach out to, or there's this cool technology which is very different from what we do, but there's no problem to try it out and see if it fits well. So, and if I want to develop a new thing, there's always that's always welcome. So you don't find resistance. You can always play with whatever idea you want to.
Publishing is important on many, many levels. Scientists want to be able to get their work critiqued and share it with the community and stuff. So the more we publish, we are going to get better scientists who are motivated to have impact through products, but also bring out the next innovation.
So we don't go out of our way to, again, find and invent problems just for publishing. Publishing is a natural outcome of what we're doing.
The career path for computer vision scientists is what we have seen so far is they're doing great work, they get promoted to the next level. As you go up and you get promoted, you get more responsibilities and more ownership to more complex issues. And as I said, you get not only to implement, but to actually influence. And not just within a team. You get to influence across teams.
It's a great time to be part of vision and AI in general. The deep learning and how we're at the speed at which we are solving solutions is amazing.
For me, I'm very career-driven and I feel motivated, I feel challenged, I feel like I grow every day. It's very fulfilling, and Amazon is I think, the best place for me to do that.
We are building something that is not there. We have to invent. And, this is a wonderful opportunity to push the envelope and to advance the state of the art, which is what scientists are all about.
Hello, CVPR. Good morning, good afternoon, good evening, depending on your time zone. Welcome to this virtual CVPR. I am Jitendra Malik. It's my pleasure today to interview and conduct this fireside chat with Charlie Bell. Charlie Bell is Senior Vice President at Amazon Web Services. This is something very well known to us in computer vision. We have all used Amazon Mechanical Turk for annotations, and we have used AWS for our compute needs. So it's a great thrill to be interviewing him, and I hope that we will get some insights from this interview, which will be of interest to the computer vision community at large. So a few words about Charlie. Charlie is a bona fide computer scientist and a rocket scientist. He started off early in his career. He worked with NASA, he worked on Space Shuttle, he worked on the Hubble Space Telescope. And then he was one of the early people who joined Amazon and was responsible for much of the work in infrastructure there. So with that, I'd like to get Charlie to answer a few questions. But first of all, thank you very much, Charlie, for taking the time. I think the computer vision community appreciates AWS's involvement and contribution to our field. And I thank you for taking the time today.
Yes, we very much appreciate the community. Thank you.
And so perhaps before we get started, maybe you could tell us a little bit more about yourself.
Yeah, Jitendra. I started out in Amazon in 1998 when Amazon was just selling books. I came into the company. We were a very small acqui-hire, and my boss asked me, "What do you want to do?" And I said, well, I'll do whatever nobody else wants to. He said, well, go build customer service applications. So I started working on that. And then a few months into it, he said, hey, I need you to run the infrastructure here. So I went over to that job, and that was absolutely a joy. I did that for 5 years, and we were in a whole period of get big fast, and we were scaling Amazon and having a lot of fun. In 2006, I decided I want to try something new, and there was this small operation up on the hill called Amazon Web Services. We were just building it. We'd actually launched, at that time, we'd actually launched Mechanical Turk, interestingly enough. It was one of the very first Amazon Web Services that wasn't related to the retail business. And so I joined the team in 2006 when we were just getting started with EC2 and S3. And so that's been 14 years of pure fun. And really enjoyed it. And we got very deep into machine learning. Amazon's always used machine learning, by the way. When I joined, we were using it in personalization. And certainly the computer vision space opened up all kinds of opportunity for us. So AWS has done quite a bit in that space. And I'm thrilled to be here talking to you.
Wonderful. Thank you very much. So maybe we can get started by talking about Amazon's investments in computer vision. What's driving your investment in computer vision, and how is Amazon applying it to the business?
Well, as I said, computer vision started to have a pretty big impact on our business a while ago. In 2013, we embarked on this idea of reinventing the way people shop. And we'd always had ideas about applying it to our fulfillment world. We began working on Amazon Go back then, and one of the interesting challenges was to figure out a way to do just walk out, where people could walk into a store, pick something up they wanted, and walk out of the store, not have to go through any headache of checkout. And so there was that, and there was other work we were doing that was very inspiring inside the company. And we saw lots of applications coming. And so AWS began investing in computer vision because our customers were starting to ask questions about it and asked us if we could help them solve problems. We'd up to that point, we'd been really focused on the whole idea of democratizing AI, the idea that you have a very small number of super capable, intelligent practitioners who could apply machine learning to various problems. But the world was going to need tools that would allow the average person to get access to it. So how could the average software developer or even non-software developer have access to machine learning and be able to do things with this fabulous new technology? So we spent a lot of time thinking about, where we wanted to invest our time. We realized that this would be all up and down the stack, that we'd need to invest in hardware, we didn't need to invest in software. Most importantly, we need to invest in tools that would make it easy to get access to machine learning, and especially for folks that weren't deeply trained. So you have the deep practitioners of it, and then you have other folks that would want to apply it to things. And so we wanted to support the entire community of people that would be doing things with machine learning. And we also saw computer vision as a super interesting area, and likewise began building that up the stack. So building tools to give people the raw access to frameworks, all the way up to having inference services where you could just feed it some pictures and then say, what's in my picture? And so there was a great need, of course, in the computer vision space to do annotation. And if I kind of wind the clock back to what we did with Mechanical Turk back in 2005 when we launched it, it was an interesting web service. We knew that when we were looking at the web service space that there would be plenty of things that machines wouldn't be capable of doing. And if you were going to build a complete application, you might need to involve humans. And so Mechanical Turk had this idea that, well, if you have an API on a human, you could call it, and the human could perform a task. We called them HITs, human interface tasks, I think was the acronym. But it was very successful. We had a lot of folks doing all kinds of things with it. We did notice that people even early in the machine learning space were definitely using it for annotation. And that inspired us later to launch capabilities like Ground Truth that took advantage of Mechanical Turk and specifically tailored it around the needs of scientists to do annotation. It's a super interesting area. It continues to evolve, and the use of Mechanical Turk. There's interesting ideas of using it for. We've launched some things to allow you to apply it to similar to the original idea of Mechanical Turk to the cases where you might have a low confidence result and you want to put it in front of a human and get the human to adjudicate what it is. So lots of stuff going on there. I mean, a good example in this COVID situation that we have, we've had customers using TextRack to process loan applications, and what they do is they look at a document, and if TextRack can't, so TextRack is sort of a it's a way to think of it as optical character recognition on steroids. Essentially, it's looking at the whole document and can extract patterns off the document, including forms and other things. But if for some reason you don't have high confidence in the result, we can put it in front of a human and augment the result there. So yeah, lots of interesting stuff there. Well, a much more efficient process is using computer vision to watch the stowers throw the stuff in bins and determine what products are in what bins from that. You eliminate a whole bunch of equipment and motion and improve productivity. So yeah, I mentioned the Amazon Go application where people, you can try that today, actually. You can go visit an Amazon Go store and just walk out. So yeah, we're super excited about what we've been able to do so far, and it's still really early. There's a lot of great stuff to invent.
Great, thank you so much. For the benefit of young people in the audience who do not remember the time before AMT existed, so people like me, when we wanted to get images annotated, we basically used to conscript our graduate students to do this, and very naturally they would be tired and sick of it. So for all of you graduate students in the audience, you have to thank AMT for you not having to do that job. So thank you. So moving on, I want to ask a bit about your organization and the role of computer vision researchers in your organization. So you've hired a lot of researchers into your organization. Many of the prominent people in the field are now working in Amazon. So maybe you could tell us a little bit about what's the experience like for scientists inside Amazon. And as a follow-up question, I would like to ask you about the culture of research at Amazon, because if I compare Amazon to companies like, say, Google or Facebook, there's a lot more publishing, a lot more papers coming out from your competing labs. So your response.
Yeah, first, so if I think about like the first half of my career at Amazon, I don't know if you can remember back to the 1999, 2000, there were a whole bunch of stories about how Amazon was going to go out of business and all the big guys were going to take over the e-commerce future. And so Amazon's always been under tremendous pressure to innovate and innovate quickly. And so for the first half of my career, we were very pragmatic. We focused on what customers were telling us they needed and what could we do to solve those problems very quickly. And as the company became more mature, we've always had a long horizon. If you think about AWS, launched in 2006, it was definitely a long bet. But we began to invest in longer horizon research, and we began hiring, especially in ML, we noticed that there was a lot of science to do if it was going to. First of all, it had tremendous potential, but there would be new science if we were going to be able to solve some of the problems. You know, the one I mentioned with Amazon Go, for example, required some really interesting problems to be solved. Like you can imagine you're trying to track somebody in a store, and their crying 2-year-old is at their knee, so they pick up the 2-year-old and they hold the 2-year-old in their arms. And now if the 2-year-old's grab something, you have to figure out, disambiguate the two people. You got two people there, you have different things. So these are complicated problems, and in order to solve them, there's a lot of basic research that needed to be done. And we began hiring scientists at Amazon. We always had the idea that we would publish, but Amazon still has that pragmatic streak from its beginning, where we realized that some of the most exciting problems to work on are problems that have applicability to the real world and data that's associated with the real world. And that was attractive to some scientists who wanted access to the data in order to test new hypotheses and develop new capabilities, and also love the idea that their research would actually be embodied in some product or capability that customers would use to better their lives. You know, interestingly, we've had people go back and forth between the academic world and the Amazon research world. But I would say the difference between us and others is we always are focused on solving a problem. We're a culture of problem solvers, and we're inspired by real world problems, which can be very interesting to researchers. But there certainly is a strong place for the academic world, and we love partnering. Certainly there are places where you're working where the headlights don't shine. It's very hard to even imagine the real world application of the basic research that you're working on. And so as the company has continued to mature its thinking about long-term research, we've continued to broaden the horizon of what we invest in, both inside and outside the company.
Yes, that's which brings me to my next point, because this has been the subject of a fair amount of discussion in computer vision, in machine learning, and in the popular press. There have been stories on that in the New York Times, which is that is the current success of AI and machine learning causing problems for the pipeline? There is this phrase, eating your seed corn. So is it the case that the success of industry means that industry recruits away all the top academics, and then we will not have a next generation? We will not have anybody to train sort of the PhDs and the undergraduates and everybody else. If that were to happen, that would be pretty terrible, I would imagine. But
I agree. It would be terrible.
Yeah. So maybe could you speak to that, and more broadly, how do you engage with academia? What are you doing to sort of till the soil, if you will, to help the source? Because academia can never compete in salaries with what industry can offer. It cannot compete on the amount of compute resources that industry can offer. So the question is, how do we have a balanced ecosystem?
Mm-hmm. Yeah, I think the basic answer is that it's a partnership for the long term. I think I would say I don't believe that dire future you describe is anything close to what will happen. It's just like I don't believe that the machine learning technology is going to take over what humans do and make us all obsolete. I think that it just opens up a wonderful new avenue for the improvement of both the application of research and primary research and discovering new things. And I think what we see going on right now, if I think talk about the spectrum of how we invest in research. So we have folks on we have an organization model inside of AWS we call service teams. So we create teams of people around a specific customer problem, and they own that problem, and they iterate really quickly, and they see customer issues and solve them quickly. And within those teams now, especially in machine learning, we're assigning science folks, because there's a lot of science that goes on in the, solving these kinds of problems. But then we also have central science teams that are doing sort of broader research and publishing some, but also applying their research out to some of these other areas. So there will be research done in particular areas of computer vision or natural language understanding, and that will roll out to the teams. And that still often can be very, we'll call it applied science, very useful for problems that we're seeing with customers. But beyond that, we also have a set of researchers that are really, they're part-time. They will often work for us a portion of time, and then they'll spend the majority of their time in academia. And we see that as a wonderful pollination process both ways. Especially in machine learning, access to real-world data sets is extremely useful, and being able to do experiments and see how they play out at scale is extremely useful. And so we find that scientists love this kind of going back and forth, and we encourage our people to do that. We encourage them to go down into service teams and learn about real-world kind of application of specific things, and then they can go back and do some research inspired by what they learn. And I think the same thing is happening across the boundary with academia. And we both share a common goal. If you truly believe in this machine learning inspired future, where machines will be doing so many things for us and making us so productive, it's going to require a lot more scientists, and those people are going to be educated, and they're going to learn in the academic world. And so a healthy academic world is super important to us. And it's why we make significant investments in grants and credits for researchers, for PhD students. We make significant grants for even just raw compute time and other things for undergraduates. We believe that we're going to have to keep going deeper into the educational system in order to bring students into this incredibly important area from the very start. And so that's a partnership with academia. We think it's really important. And as I said, we'll partner with, we're not, in no way are we going to want to or would ever be able to, but would want to remove the capability of academic institutions to both do research and to bring up the number of folks that are going to be needed for this area.
Thanks. Yeah, maybe you could elaborate a little bit on the program you have for supporting compute at universities, because in practical terms, this is one of the things that is difficult for faculty and grad students. They simply don't have access to the kind of compute that is needed today for doing cutting edge research. And I think it's not just an issue for Amazon alone. It's really, I think we have to figure out a solution at the level of the federal government, Amazon, and the universities, a solution which will help support the ecosystem. But that's a topic for a longer discussion. But if you had anything to say from your perspective.
Yeah, well, we do have we have specific programs in place with major universities on research, funded research, as well as these sort of part-time back and forth programs where we're bringing folks in and having them do funded research on directed things problems that we see and need to have solved. And we're doing that with Carnegie Mellon, MIT, Stanford, Berkeley,
Yes,
very
I know.
important there, and a number of schools. And each of these schools, if I would encourage folks that are listening, we have specific programs in place. Look, the cloud has created a wonderful opportunity to just as it's done for startups, where I had an interesting conversation with a venture capitalist back in 2009. I was visiting the Silicon Valley, and I wanted to talk to some of the companies that were in the portfolio of this venture capitalist. And the venture capitalist said, over lunch, he said, you're disrupting our business. And I said, how are we disrupting your business? And we couldn't be disrupting you. He said, well, because you guys make it so cheap for people to try out new ideas, we used to be able to go to these companies and they needed our money. And so we would get a piece of the company. But now we're going to companies and they're telling us, well, I run my infrastructure off my credit card and I already have 18 million customers. Why do I need you? And what was very inspiring for me with that conversation was the idea that there were so many new ideas that were being funded and were happening because the accessibility of just this raw compute infrastructure and everything else was just so much easier and cheaper to get a hold of it. And so I think that's what we've been able to do too with academia, is to reduce the cost and then to make available some of these programs, because it's in everyone's interest to become educated on the tools and to have access to the resources to do the research. So just by making this stuff so much cheaper and easier to get at, and in fact, one of the areas that I am very excited to see papers and other kinds of research is humans are tool builders. We're very that's what's differentiated us, and I see so much coming out where of our universities and environments of great tools that are further going to accelerate research and remove some of the boring, heavy lifting from getting things done. Just as Mechanical Turk removed the boring, heavy lifting of annotation from you guys.
Yes. So maybe we can now move to a slightly broader question, which is on computer vision as a whole and across multiple businesses. And the reason I ask is I'm somebody who's been in the field for many years. And for many years, computer vision was purely an academic discipline. We wrote papers, we talked to each other who wrote papers, and we discussed our last papers. And most of what we tried wasn't good enough to work in practice. Now that has changed. And that's why we have so much of computer vision now happening in an industry, both research and development and productization. So from your perspective, can you speak to how you think computer vision technology will play out across the board? I mean, Amazon is in many businesses, so you probably have a perspective on this.
Yeah. Well, first, we're seeing it explode across the board in what it can be applied to. As I mentioned, Amazon Go. We also we have a capability of delivering packages called Prime Air that entirely depends on computer vision. I know there are folks that are working on the problem as sort of human managed drones that would deliver things, but fundamentally, if you're going to scale delivery to Amazon scale and make it possible to do airdrop delivery in your backyard almost anywhere, you fundamentally need autonomous vehicles in the air. And the only way that people are going to accept a bunch of autonomous drones flying around is if they're incredibly safe. One of my favorites is there's a gentleman who had a problem. His cat kept bringing home dead animals. I don't know if you've seen this, Jitendra, but the cat would bring a dead animal in the middle of the night, and of course this was very upsetting to the household. And he thought for a moment. He said, "Well, wait a minute. I believe computer vision might be able to solve my problem." And so what he did is he got a little Arduino board with an actuator that could bolt the cat door closed, and he got one of our deep cams. We have a camera that we created to help educate people on computer vision. It's a little kit you can get off Amazon, and comes with some deep learning capability that you can train models with. And so he trained models to first recognize when the cat was coming to the door, and then recognize whether the cat had an animal in its mouth, whether it had a dead animal in its mouth. And so his serial killer cat could be spotted trying to come back in the house. He even built his program so that every time the cat came back and got locked out, couldn't bring the dead animal in the house, he would send money to the Audubon Society as sort of a payment for having killed that animal. But the point is, computer vision is becoming so much more accessible to so many more people. And I think we're going to just see, within our company, within our customers, we see it being used by so many customers for different applications. It can be used in industrial settings to look at the quality of things coming down the line. There's this very interesting case of finding trafficking, human trafficking, and basically saving people from situations that are just horrible. And there's some wonderful stories of people being rescued through computer vision technology. So it's a very exciting time, I think, for how this will be applied. It's wonderful to see the growth of the space.
So what are some of the major trends in computer vision that you see impacting the field right now?
It's a great question. I think the first would be we're definitely going to need better benchmarking and open standards in computer vision. We're seeing increasing need to earn trust. And example, I used to work with my daughter when she was studying machine learning, and she was doing some computer vision assignments. And I remember being very impressed with the deep neural networks and what they could do, but they were entirely unexplainable. As a computer scientist, I thought, wow, I have no idea what's going on inside of that black box. And I think what we're seeing in the industry is that in order for machine learning, computer vision specifically, to be more trusted in what it's doing, we need good benchmarks and public and open standards so the technology can be validated. I think another important area is accessibility. As the demand is quickly outstripping the supply of the people who can develop models and deploy the technology, we're going to need much better tools that enable the average person, average software engineer, or even end user to be able to get at the technology and to deploy it. I did talk about that a little bit earlier, but I think it's a super important point to underscore. And then I think another one is that we've often thought about computer vision as something that just does things on its own, but we're going to have to think of it in tandem with human capabilities, and so better integration of humans in the loop, and both let the computer vision do the boring, dangerous things that we don't want humans doing, and then keep the humans in the loop to help us with accuracy and collaborate really with this new technology.
Great. I wanted to ask you about applications from the customer perspective. Are there any which have really surprised you?
Oh, wow. Well, I have to say it is definitely one of those across the board things. They're just all over the place and in so many different industries and so many. It's just the broad range of how people are applying it. I'd say example is Deliveroo using it for content moderation. Making sure that that things that belong in front of people are there, and things that don't aren't. Intuit actually uses computer vision to help their customers file their taxes faster and more efficiently. The NFL uses it to do real-time analytics and to monitor players for health and safety. We recently announced the World Wildlife Federation is using computer vision to better understand the size and health of orangutan populations, an endangered species. And then, of course, I think I mentioned this before, in the COVID pandemic we have right now, employing it to see who might be sick coming into an environment is interesting, and it's amazing how fast people have moved to deploy computer vision as a solution to this urgent crisis.
Great. I want to close out with an important question given the time we are in and given the time when this interview is being conducted. So diversity and inclusion have been important concerns for the technology industry in general, and specifically for AI and machine learning. So would you like to say something about what Amazon is doing in this direction?
Sure. Well, first of all, I've been at Amazon 22 years, and it's always been one of the most diverse environments in the world, from my perspective. And the company's always been a proponent and a recognizer that viewpoints from all different corners come together to give you better ideas. And so we've always believed in that, and we continue to invest in improving the engagement of different groups. I think a super important thing we can all work on is education. We need to work on bringing more people from diverse backgrounds into machine learning and computer vision, software engineering in general. I mean, we basically need to increase the participation, we also, I would point out, inside of our computer vision machine learning teams, we have an amazingly diverse team of folks. It's a technology that I think benefits from worldwide involvement. We have offices all over the world, and bringing people in to our technical organization from diverse backgrounds has really helped us build better products. We sponsor and host events such, for Code.org as an example, Girls Who Code. We partner with the Nita Borg Institute to sponsor events like the Great Grace Hopper Celebration for Women in Computing. And we also help students enroll in national programs like Aspirations in Computing. So it's super important. We believe training the next generation of leaders.
Indeed, and I hope that this is an inspiration to all the students in the audience, because the frontiers for computer vision have really expanded in the last several years, and that's wonderful. So as a closing question, I want to go a bit bigger picture and philosophical, and this is a question from the audience. And let's put some context here. There is in the popular press a lot of discussion about AI and the impact of AI. And this ranges from all the fears of, there will be this AGI, it will run amok, it will decide whether or not to bother with the human race anymore, and so on. And there is that at one extreme. And then there are the fears about unemployment at another issue, the issues with bias, etc., etc. So what I'd like is from a very practical and pragmatic point of view, what do you think will be the consequences of AI in the next few years? Is it the next industrial revolution, What do you think? What do you see in the future?
I do think it is the next industrial revolution. If I think about what we did with the cloud, that was a revolution. But I think it may end up, when we look back 1,000 years from now, being dwarfed by the revolution happening in AI and machine learning. It has this tremendous potential to better our lives. People go back and look at history, and each time we came up with things that make our lives better and more productive, they've been beneficial to the human race. There have been no examples of a new technology that enabled productivity the way ML and AI can do, and you had a bad result. So I'm very optimistic. I think we're going to see tremendous improvements in human productivity, which is better for all. It essentially will lower the cost of getting anything, and anytime you lower the cost of getting it, you get a lot more opportunity. It's not a constraint. So I am super optimistic about it. I'm not an evil AI kind of type. I believe that we'll continue to develop AI in a positive way, and it's because its heritage will be positive.
Great. So Charlie, you don't think the future of AI is that dark, is it?
No, I think if you look at human history, it's just it's very clear that as you get advances like this that improve human productivity, everyone benefits. And I think, first of all, there's been no advancement like this. This is machine intelligence, and it's what differentiates humans from animals. And now machines will be able to do things for us that are mundane and boring, and free us to do all kinds of new things. And so I believe we're kind of at the dawn of a wonderful new era in human capability, and machine learning will make that possible. And I think that there are those who say, there will be evil AIs, and there's nothing evil evolves from the kind of good that we're asking them to do for us. And in fact, we get into an interesting debate. I've been in these before about how AIs can evolve, but I'm very optimistic about the sort of history of how development of new productive capabilities for humans has benefited us in the large, and I believe for sure that's what's going to happen with machine learning. We're already seeing it. I mean, I'm seeing all kinds of different applications where, as I mentioned, stopping human trafficking, or benefits to COVID, or there are companies applying this to recognizing all kinds of situations and responding to them. And I just think it's going to be a boon to humankind as we deploy this further, and it'll free us up to do things that aren't repetitive and useless.
Wonderful. Thank you, Charlie. It's been a pleasure chatting with you. And on behalf of the computer vision community and CVPR 2020, I want to thank you for taking the time and sharing your insights from your vantage point at Amazon. I wish that we were in a real physical environment and you could have heard all the claps. So now you just have to imagine it virtually. But thanks again, and it's been a pleasure.
And that day will be upon us soon. And I believe machine learning will get us there. So thank you.
Machine learning is going to continue to improve the lives of truck drivers.
Using computer vision and machine learning, we wanted to see if we could create an automatic analysis of autism and autism spectrum disorder.
Machine learning allows us to get very, very quickly to very complex data.
Machine learning can actually directly contribute to understanding our planet. we can use machine learning and computer vision analysis to assess things like facial expression and attention. And so we built a set of movies that elicit these behaviors and use the camera in the device to measure the child's response.
AWS is allowing us to go through the machine learning phase together, and we can now predict future performance based on the data of the past.
The innovation that Convoy has brought is we can figure out where the right truck is for the right load anywhere in the country, and using machine learning match the right trucker at the right price to move a shipment from point A to point B.
We sail around Antarctica in 196 days with 3 vehicles. You will need to understand the risk of collision with icebergs, which can be the size of small countries. Drones are equipped with cameras. The problem being, when you're at sea, the ocean moves, the waves move, and we need to train machine learning algorithms so we can navigate it. How do we use the technology that we have developed and put it at the service of the planet?
We're embracing machine learning. We're embracing AI. We're going to truly change the game.
I like to have home time because I don't get a lot of time at home. But that's what the Convoy app does for me. It helps me be at home more.
If we can do just a small thing to change one kid, I think I would go to sleep with a smile.